is equal to pi on 3. First I need to explore this number a little bit more in here, so I'm going to let z equal x plus iy. That means z minus 1 is going to be x minus 1 plus iy, and z plus 1 is going to be x plus 1 as the real parts, plus iy. I'll realise the denominator, so I'll multiply by the conjugate of the denominator. Doing that across the numerator, this times this, difference of squares, so that's going to equal x squared minus 1. This multiplied by that, I'm going to get plus iyx plus iy minus iyx, minus times a minus is a plus iy. This times this gives me minus I squared y squared. Denominator is a bit easier, it's just a difference of squares, so we know it's x plus 1 all squared, and we know from experience that's going to be plus y squared. Simplifying out the numerator, x squared, this becomes plus y squared minus 1, these two terms here cancel, plus 2iy, and the numerator stays as x plus 1 squared plus y squared. Okay, and so I know that the argument is equal to pi on 3, so I know that tan of the argument, so tan of pi on 3 is equal to y over x, in this case the imaginary part over the real part. Our imaginary part is 2y, our real part is x squared plus y squared minus 1. Tan of pi on 3 is an exact value as root 3, so I get root 3 is equal to 2y over x squared plus y squared minus 1. Now I just need to do some algebra manipulation, so I'll bring the x squared plus y squared minus 1 over here. I'll divide this side by the root 3, I'll get 2 on root 3y, that just suits my purposes nicely. Bring this back across, x squared plus y squared minus 2 on root 3y is equal to, I'll bring this 1 over here, is equal to positive 1. Okay, starting to look like a circle, I just need to complete the square on this term here, so I get x squared plus half of this, y minus 1 on root 3, all squared. By doing that I've added this square, which is 1/3, so I better add 1/3 to the other side. Oops, plus 1/3. Now it definitely is looking like a circle, so I've got x squared plus y minus 1 on root 3 all squared. This becomes 4/3, and so what I have is a circle. I have the centre at 0, 1 on root 3, and I have the radius. Square root of this, square root of 4 is 2 on root 3. 2 on root 3 there.